Hi everybody, it's Miss Austin. I'm going to be going over the Unit 3 Lesson 6 problems. Those start on page 30. Sorry guys, 42, on page 42. The big idea in this lesson is that when you have the square root of x equals an answer, there's only one solution because there's only a positive number that you can take the square root of. But when you have x squared equals a number, there's two different numbers, the positive and the negative, that can give that answer. Okay? So number one says, select all solutions to the equation x squared equals 7. So technically to solve that, right, to undo square root or square, you take the square root and the square root of both sides. Again, if you're thinking about it logistically, what number can you square that will make 7? Well, you could do the square root of 7, because the square root of 7 times the square root of 7 is 7. But you could also do negative square root of 7, because a negative times a negative will also give you the 7. So when it's in this form, x squared equals a positive number, you get both the positive and negative solution. So we've got A and B. Okay. Number 2, find the solutions to each equation if there are any. X squared equals 9. What numbers can I square that will give me 9? Most of you can just think about this off the top of your head. I mean, we can actually go through and solve it. To undo square, we square root, x equals the square root of 9 is 3. What other number, right? 3 times 3 would give me 9. That would work. And we could also do the negative. Negative 3 times negative 3 could give me 9. So we've got 3 or negative 3. Okay, now this is where students, they might think the reverse is true, that could be 9 or negative 9, right? But the only number that you can put in there that when you take the square root of it, you will get 3 is positive 9. And technically the algebra behind it, let's do that, right? How do you undo square root? You square square. That undoes the square root. You got x equals 9. Negative 9 wouldn't work. You can't take the square root of a negative. The definition of square root is that a number times itself will equal this. All right, and then letter C, what number can I take the square root of that I get a negative? There's no number that you can put in there that will give you a negative 3, because definition of square root is that it's a number times itself. So this one has no solution. And eventually we're going to learn that we're going to expand this to say no real solution, because mathematicians did adjust this idea and they came up with a new set of numbers called imaginary numbers. So you could say no solution, or you could also say no real solution. Okay. Number 3, if C is a positive number, how many solutions does x squared equals C have? Explain. Well, we could look right up here at the problems we just did. X squared equals 9. How many solutions does it have? It has 2 solutions. It has the positive and the negative number that would multiply to that. It has 2 solutions because you can take the positive, right, and the negative. For example, let's just, do 16. X squared equals 16. 4 times 4 will give you 16, and negative 4 times negative 4 will give you 16. So the answers here are 4 and negative 4. I just used that to explain, right? You could put a 4 in there or a negative 4, and you would get C, if C is positive. Okay? If C is a positive number, how many solutions does this have? Well, look up above. Look at letter B. If this is positive, which it was, how many solutions does this have? Well, How many numbers can you put in here? Let's do a different one. Let's use 16 again. Oh, actually, let's switch that. I needed to do the other way. What's the only number that I can put in there that will have a square root of 4? The only number that's going to work is 16. You can't put a negative 16 in because by definition of square root, this is not a number. It's undefined. So it only has one solution. Because there is only one positive number that will give a square root. And you might have a better way to word that than I do. All right, moving on. Number 4, some review questions. Suppose a friend missed class and never learned what 37 to the 1/3 means. Use exponent rules. Your friend would already know to calculate 37 to the 1/3 all raised to the third. Well, from our previous courses in Algebra 1, we know that when we have a base that's being raised to a power, all raised to another power, we can multiply those. So 37 to the 1/3 all to the third is actually 37 to the 1/3 times 3. So I'm going to multiply these two. Hopefully you can see that those 3's will cancel. You could also put a 1 under here if that helps you. That's 3 over 3, which is 1. So this is just 37. It says explain why this means that 37 to the 1/3 is the cube root of 37. Well, look, if I cover up this right here, which is 37 to the 1/3, when I raise that to the third power, I get 37. Doesn't that mean if I take, let's just replace that. Instead of writing it to the 1/3, let's put 37 like that in cube root. Raising it to the third power, what does that third power do to that cube root? They're inverses of each other, and you're left with 37. So that means that the 1/3 power means cube root. This number down here in the denominator, that's the root we're taking. And that's a review from lesson number 3. Oh yeah, it says it right here. All right, number 5, another review question. It says evaluate. A lot of times students get confused on directions. Evaluate means figure out the answer numerically. Now I'm going to do this by hand. You could also just type it into a calculator. So for me, I like to have it written in radical form. So this means the cube root of 8 to the 5th. Again, you could just go type this into your calculator right now and you'll get the answer. I want to show you how to do it with your brain. So now I don't want to do 8 to the 5th. That's huge. I'm going to do this part first. I'm going to do the cube root of 8. So I'm going to rewrite this like this, just so you can understand. I'm going to do this first. Well, what's the cube root of 8? That's actually just 2. Now raise 2 to the 5th power. I can do that myself. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Now, if you type this into a calculator, guess what you get? 32. All right. Also review, that's from lesson 4. Write each expression without using exponents. That means they want them as radicals. So, not enough space for me. So 5 is the number in the radical. The denominator is the root you're taking. The numerator is the power. It can go right here on the 2, or the 5, sorry, or you could go like this. Either way, same thing. All right, how about letter B? It's a negative. Well, that means, right? Well, all a negative does is it creates the reciprocal. So sometimes what I do is I just do the positive first, and then I worry about the negative in a minute. So this would be the square root. When it comes to square root, you don't have to put the index in too. You can if you want. And it's being raised to the third. Okay. And now the fact that it's a negative, all that means is I got to take this answer and put 1 over it. So it's 1 over the square root of 4 to the third. Okay. And, I wonder, in the answer key, did I simplify that? Because technically, right, that would be what? What's the square root of 4? 2. And what's 2 to the third? 8. I'm okay if you left it like this. It said without using exponents. Oh, did it want me to? Oh, maybe it did. Oops, Miss Austin. Maybe they still consider that an exponent. Okay, let me, one more time. How did I do that? I took the square root of 4, which is 2, and then I raised it to the third power. So this would be the final simplified answer. This one, we could do the same thing. What's the square root of 4? 2. Oh, that was this problem. Duh. This one, we can't give an exact answer. I would just leave it like that. There is no cube root of 5. You could try it the other way. 5 squared is 25. Is there a cube root? No, leave it like that. All right, guys, I hope that helped. I will see you soon.